today we'll cover section 5.4, which is product to sum and sum to product formulas. The previous section, which was 5.3, we covered some formulas, and one of those was the formula to find the cosine of the addition of, well, let's write down the difference of two angles. And then we had another formula that was used to find the cosine of the addition of two angles. Do you guys remember those? Yes? Anyone who has their notes available could tell me? I don't want to mess up. It's a like cosine, cosine, sine, sine, and then like we still have a plus. Let's see.
Yeah, that's right.
Ooh. Maybe you guys should memorize it too. Sine, sine.
Sine, sine. We shouldn't memorize it anymore.
All right, and then the other one for the addition, that will be cosine alpha, cosine beta, minus sine alpha, sine beta. Okay, so those formulas, I believe they're called, I will have to double check on the name. But what we're going to do is we're going to go ahead and derive by using those two formulas. We're going to substitute them. So right here, we're going to substitute what we got here. And then for the other, which is here, we're going to substitute what we got here. All right? And what I would like for you guys to do is just try to do it on your own. And then that is actually part of that activity that I was telling you guys. So you're going to use what I gave you to do that, and then you're going to derive the formula. And let me tell you which one you're going to get. You're going to get the very first one. Yes, the first one. Now I'm going to write down the answer I have so far so that you guys could check. It is very important that you guys distribute that negative sign, okay? I hope you guys did. Who forgot about that sign? No? Especially this one, right? Like that's the one that you have to make sure you take care of that. Oh, wait, Cecily, don't move, Cecily. Don't move. Don't move. Keep doing what you're doing.
Keep doing what you're doing.
Do it. Oh. Yeah. Okay, hold on. I'll just get your pen. There you go. Perfect. Oh, I recorded that. Okay. So right here you can see opposite signs, right? And then we have, so far we have sine alpha, sine beta, plus sine alpha, sine beta. So how many of those do we have total? Two. Okay. And so let's keep in mind where I am trying, oh, and today I forgot my mouse. Where we're trying to get is to this formula right here, right? So far what we have, I'm going to write again what we had on this left side, okay?
But you have to write it twice.
Where?
On the two signs.
Yeah.
Oh, no. Because the two that already accounts for it, right? Thank you. So I'm going to write this again. This is what happened. This is not calibrated. All right. And now what we're going to do is divide everything by 2. So if we divide everything by 2, of course, right here, 2 over 2 is a 1, right? And then we will just have sine alpha, sine beta. And on the right side, instead of having the whole expression divided by 2, I'm going to factor out the 1/2. Yes, exactly. Okay, and then you can see that it's the formula number 1, which we have there. But of course, sine alpha, sine beta is on the other side, right? But we know that that is okay. They're still the same thing. To solve the problems from example 1, we're going to be using those 4 formulas. Let's just refer to them as formula 1, 2, 3, and 4 for this lesson. Those formulas will be provided to you on the test. You don't have to memorize them. And again, I do that because there's a lot of positive, negative, 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 positive, and so I don't want you to mess up on those things. I did give you those formulas on the test. Yes, I did.
I thought we had to memorize them.
No, those, I gave those.
I was about to ask her.
No, I gave those. Because I don't know them. That's my rule.
Oh, yeah.
Okay, so those formulas you will be using here, so please get to work. You're going to work with your partner or work alone, if you prefer. And then we'll be checking the answers. It's a lot of stuff. Would you like me to see one example before you start?
Yeah.
Okay. So let's see. So from formulas 1, 2, 3, 4, which one are we going to use for part A?
One.
Formula 1, right? So formula 1 states that to find this expression, we will need 1/2 of the cosine of the first angle, which is 8x, minus the second angle, which is 3x, minus the cosine of the first angle, which is 8x, plus the second angle, which is 3x. So that's what we need to do for part A. Now, what we're going to do is simplify, and we're going to simplify what's inside all the parentheses first. So 1/2 cosine of 8 minus 3 is 5. So we have 5x minus the cosine of 11x. Okay, guys, so that will be the final answer. Now, it's important, can you wait a second? It's important to notice that you might be tempted to combine the angles. Don't do that, because 5x is different than 11x. It's like we're talking about 2 different angles, like, let's say 55 degrees and 5 degrees and 11 degrees, or 55 and 110.
If it were the same, like check them.
Yes, only if they were the same, yes. Since here they have opposite sides, if they were the same angle, you could just say did they cancel or 0. But no same angles, that's it, that's the final answer. So now can you guys try to do part B? Yes? It's pretty easy.
What did you hear?
Yes, what is your question? Okay, I'm gonna write down my answer, guys. So please just make sure you check with yours.
Trick us later and be like, psych, it's hard.
No, this lesson is easy, I promise. There's no trick to this one.
The other one, okay, this is easy. Okay, here's the hard part.
No, the other formulas look hard, but they're not. From the formula, it's just the formula.
Also, like, you
Uh-huh.
have to, like, have it.
There's no like conversion that we're doing. We're just taking it from the formula.
Sounds like,
Yeah.
we're all just expecting it.
I know. Okay, so I would like to just get the answer from you guys, and then if we can all agree, we will move on. I really miss my mouse. Okay, so checkpoint 1 for part A. Any volunteer? Uh-huh.
Cosine 3x
Uh-huh.
minus cosine 7x.
7x. Does anyone second that?
I agree.
Yeah? Okay.
Third.
Say aye.
Aye.
Okay.
Aye.
All right. Part B. Any volunteer? Okay, Jennifer?
1/2 cosine 6x plus cosine 8x.
Okay.
Aye.
Do you second that? Yes? You say aye? Yes, aye. Okay.
Okay.
All right. Very good, guys. Now, the next formulas, I know they look a little intimidating. They're not. We're just going to be substituting same way. So I'm going to show you guys a very quick proof of it, okay? I'm going to write it down, and then I'll give you guys a few seconds to copy it, okay? Okay, so we're going to prove why this formula is true, and if I remember correctly, we're going to arrive to this formula here, okay? So what I'm going to do is make this right side look like the left side like we do with identities. That's what I'm doing. So in this case, I'm going to use a little trick in math, which is to multiply by 1. That's or divide by 1, right? And so here you could use several different combinations that will equal 1, such as 2 times 1/2. Isn't it true that this is 1? Yes? Okay. So I'm going to use that trick right here. It's going to look a little bit weird. Actually, I'm going to need more space. But I'm just working on this left side, right side, okay? Okay, so it would be 2 times 1/2, and then times. What are you doing?
Oh, I was giving you thumbs up to the picture.
Oh. Maybe you should just take the picture when everything's written, Jonathan.
Oh, well, Maddie's giving
Jonathan something.
Oh, because he's like the professional.
Jonathan couldn't handle it. What?
The question is what?
No, that's good. That looks good. I am hungry.
Turn the air on.
Okay, yes.
Warm in here.
Okay.
I just started feeling the temperature. I put 5 minutes storage.
Okay, then Peter, stop. I was cool. So as you can see, I already wrote down part of the formula. We have this number 2, which is here. And so what I try to do is multiply everything by 1/2, as you can see here, and that is just for the purpose of canceling the 2, as you can see here. That was the whole purpose of that. Now, what I did is that I wrote down the expansion of this part right here is what you could see here. And the expansion of the other part that you could see here is what you will see here. And so for that, I ended up using the formulas that we use in section 5.3. No. that doesn't look like. Okay, I need to revisit this one. But anyways, the goal here is that you end up combining all of your angles because they have the same denominator. I need to go back and tell you guys where those two formulas came from, okay? So you end up combining all of them. You can see that beta will cancel here, alpha will cancel here, and we are left with the sine of 2 alpha over 2 plus the sine of 2 beta over 2. And so here we cancel the 2's because they equal 1, and that is how we end up with a sine of alpha plus sine of beta. Okay, and that's it for that formula, but I'm still not very happy with this little proof. So I'm going to give you guys about 1 minute to copy it, and then I can go ahead and check why those two formulas were used, okay? Okay, so I'm going to attempt to explain that better. Okay, so I'm going to need your attention. So what we used is the fact that the formula for the sine of alpha times cosine beta is going to be equal let me just kind of change I'm going to do the following. I'm going to change the variables so that you don't get confused with our real problem. So if we were to find the sine of theta times cosine of omega, something like that, you will do the following. By following the formula on the very first slide, can you guys look at it? On your first slide, or actually you could see it on the board, and that will be formula number what? Number 3, right? So as you can see, we need 1/2 of the product, and then we use the following quantities. We use the sine of the first angle, which there I'm calling beta, plus the second angle, which I'm calling omega. But then we add the sine of the first angle, which is theta, minus the second angle, which I'm calling omega. So what I'm going to do here for what I did with the proof, what I should have done from the beginning, is that my angles, what I'm referring to here as theta, that is actually going to be the alpha plus beta over 2, right here. And right here, what I'm referring to as cosine of omega is going to be the cosine of alpha minus beta over 2. So that is just so that we could actually prove the formula that we were trying to get to, which is this one right here. That one. Okay, and so I'm going to do it again just so that you see that we arrived to that one right there. Okay, now that I understand a little better how to do it. Okay, so we go from there, and we know also that we're going to use that little trick that I was telling you, where you multiply by 1 by doing this, right? Because there you're just multiplying by 1. And so what we're going to do is expand it. So this will look like sine. Instead of theta, we write all of this right here. Alpha plus beta over 2. And then instead of omega, we write all of this right here. So that's where all those little alpha plus beta, that's where they come from. Right here, okay? That's omega, that's theta. The two angles in question. And so here, same thing. So this beta will be alpha plus beta. And then here we have to be careful because we have a minus. So we're actually going to have minus alpha plus beta over 2. And you could see already everything is divisible by 2. Or it has that same denominator. So then we will say sine of alpha plus beta plus alpha minus beta over 2 plus sine of alpha plus beta minus alpha plus beta over 2. And then again, we could see that beta will cancel here, alpha will cancel here, and then we will have sine of 2 alpha over 2, sine of 2 beta over 2. So that will be sine of alpha plus sine of beta. Okay. Yeah. So that's better. Okay, so now using the formulas is fairly easy as well. I'll write them on the board in a minute. And so for the very first one, I'll do the first problem with you guys, and then you guys can do the second one. So for the first one, we're going to use formula number, let's label our formulas. This will be number 5, number 6, number 7, and number 8. Okay? So which number will we use for the next problem?
5.
5. So formula number 5. So sine of 9x plus the sine of 5x. And so just following the formula, we need 2 times the sine of, not alpha plus beta, but the first angle, which is 9x, plus the second angle, which is 5x divided by 2, and then times the cosine of the first angle, which is 9x, minus the second angle is 5x divided by 2. So that is what we need to do. And it's pretty easy to work. We work from the inside out. So this will be the sine of 10x over 2 times the cosine of 4x over 2. And of course, you can see both numbers in the numerator are divisible by 2.
It's not 10, it's 14. It's 14. Not 10.
Oh, okay. Yes. It is 14. Thank you. 14x. So that will be 2 times the sine. 14 over 2 will be 7. So 7x. And then cosine of 2x. And that's it. Pretty easy, right, guys? Yes. Okay, so for the next problem, you are going to do that one on your own. And so for that one, which formula would you use from the sum to product? Formula 8. Okay, so that we have cosine minus cosine. Yep, that's correct, formula 8. So please work that problem out. And then we will check. So just to check our answer for part B, we use formula 8 on that slide, formula 8. And so the answer should be something like that. Now, is it okay to have an angle such as that, like x over 2, 7x over 2? Yes, it's fine. There's nothing wrong with that. Okay, so let's go to the next slide. And those two, I think you guys can do them. So you will use more of those formulas, right? So that will be your checkpoint. So for checkpoint 2, part A, which formula would you guys use? Formula 5. 7. Like you're eating. Okay, so we're gonna check our answers for checkpoint 2. Okay, so I got that for part A. If you guys see a mistake, please let me know. Do we agree on that? You're still working on it? Okay, and then for part B, here's my answer. You see something wrong with it or you disagree, let me know.
Oh.
Yes.
So we can delete the brackets?
Yeah, they're not necessary at that point.
Okay. Is my math class gonna be okay with that?
Oh, I don't know. What I would suggest is that you look at the example and then see how they enter the answer. See the bracket, Ruben, whether we have it or not, it has the same meaning because it implies multiplication.
Oh.
Yeah. If we had a quantity that was something like this, for example, then yes, we want to make sure that we have either parentheses or brackets, so that we know for sure that the 2 goes here, but it also goes here. With multiplication, it's not necessary because the 2 will multiply the cosine times the cosine whether there is bracket or not. But right here, if you didn't have the bracket and you just had 2 cosine here, the 2 will only be multiplying the first quantity and not the second one. That's why you gotta put the bracket there. Okay? All right, so next one, we have an identity. Your favorite ones. So let me see, what do I want to use? Okay, so I'm going to be using the sum to product formulas. So I'm going to solve this identity, guys, and then you guys will do the next one, and then we're done with the whole lesson. Can you believe that? It doesn't happen too often in this class, right? But you're going to use your time wisely, right?
Yeah.
You'll have to study. If you're not studying or doing math homework, then we cannot do it. Okay, so right here I'm going to use which formula for the top, the numerator? 5, 6, 7, 8. 8. Okay, thank you. So that one says -2 times the sine of the first angle, which is 3x, plus the second angle, which is 5x, divided by 2. And then times the sine of the first angle, 3x, minus the second angle, 5x, divided by 2. And that's it, right? For the numerator, yes. Now the denominator, I'm going to be using formula number 5. So that will be 2 times the sine of 3x plus 5x over 2, multiplied by the cosine of 3x minus 5x over 2. Now here, sometimes students tend to think that because 5x is greater than 3x, you have to write it down first. That's not the case, okay? You will still leave it like that. We're going to end up with some negative angles, but that's not a big deal because we know odd and even functions, I hope. So what I'm going to do here is just going to simplify it a little bit, okay? So first of all, we could divide the -2 and the 2, and so that will just be -1. Now what I'm going to have is sine, and I'm going to combine what's in here. So we have 3x plus 5x, that's 10x, divided by 2, 5x.
This is 8x.
Also, it's 4x.
Oh, sorry.
Yeah.
Oh, gosh.
I like it.
I don't know what's wrong with me. Okay, 3x plus 5x is 8x. And then divided by 2 is 4x. Okay, thanks. And then sine 3x minus 5x, that's -2x.
2 negative x.
Divided by 2, -x. Okay. And then on the bottom, we have sine, and again, 3x plus 5x, that's 8x divided by 2, that's 4x. Okay, and on here we have sine of, not sine, but cosine. Gosh. Cosine, and 3x minus 5x is -2x divided by 2, so that will be -x. Okay, so we're almost there, guys. Now, you could see that sine of 4x and sine of 4x are exactly the same, right? So we could cancel them because they equal to 1. But we still have this negative sign out here, so let's keep track of it. Now, because sine is an odd function and cosine is an even function, I have something to say about that. So sine of negative x is the same as the opposite of sine of x. And cosine of negative x is the same as cosine of x. And how do I know that? Because this is an odd function. And this is an even function. So what I'm going to do is I'm going to substitute this part right here with that. But keep in mind there's still another negative there, okay? We're going to end up with 2 negatives. And then I'm going to substitute this part right here with this. Are we okay with that? Look at it. See where I'm getting my substitutions from? Yes? All right. So this negative, I'm just going to write it down with black so you don't miss it. So this there. And then in red, I'm going to write down the other negative. So that was negative sine of x. And then on the bottom, we just have positive cosine x. Now, what do we get? Negative times negative, right? Positive. So we just have, whoops, and I should have been working down. Sorry. So it should have been this. So positive sine x over cosine x, and I think you all know what that is equivalent to, right? Tangent of x. And of course, that's what we were trying to prove. So we have verified that the identity is true. Now, this is a very good example of why identities are useful. I'll give you time to copy it. So you guys know this is pre-cal, right? So it's to prepare you for calculus. So, of course, it will be way easier to answer a question like this one instead of the first one, right? Don't you guys think so? Yes, a lot. In fact, there's just a formula for this. Okay, so one of the reasons for identity, so I'm just going to ask you if you could please solve that one the same way. And you're going to work the left side. What you need to get is this stuff right here. Once you do that, we're done with the lesson, okay? And then we can take a restroom break.